Hello, everyone. Good afternoon, and we apologize. You think at this point we'd be good to go with technical difficulties, but here we are, and we're really happy that you joined us today for the second in a 5-part webinar series called Strengthening the National Weather Service Drought Toolbox. The series is brought to you on behalf of the National Weather Service and NIDIS, the National Integrated Drought Information System. Today's webinar will focus on monitoring, predicting, and communicating flash drought in your area. Just very quickly, NIDIS, for you who are not aware of this program, it was established in 2006 by Congress to help the country be more proactive in terms of preparing and responding to drought. And we do this through a number of different ways, including regional drought early warning systems, drought prediction and forecasting, and we also host the U.S. Drought Portal. And we do all of this with our partners, including the National Weather Service. So a quick overview of today. We'll start with a kickoff of a recent National Flash Drought Workshop, a very brief overview. You'll have plenty of links to dig in and get more information afterwards. And then we're really excited to have a kind of a case study, local perspective from the Midwest on flash drought. So thank you, Jeff and Molly, for joining us. And then finally, we'll wrap this up with highlighting some new developments in monitoring and predicting drought from Adam from the Climate Prediction Center and Marina. If you have any questions or comments for speakers throughout the entire webinar, please add them in the question box and we will answer them at the end. If we don't have time to get to those questions, we will make sure we address those after the webinar. And just a reminder that this webinar is being recorded and that we will also be sending out a recap when this is all done. So now I'll pass it straight over to my colleague at NIDIS, Sylvia Reeves, who will go ahead and give a brief overview of this recent workshop.
Good afternoon, everyone. It's a pleasure for me to update you on the NIDIS Flash Drought Workshops from 2020 and 2023. In 2019, I'll start there, in the midst of a nationwide attention-getting series of flash drought events, NIDIS took on the task of organizing workshops on the topic. One goal was to define or at least describe flash drought, and that's the definition you see on the screen. Flash drought is described as the rapid onset and or intensification of drought conditions that culminates in impacts to one or more sectors. Flash droughts often last for a shorter period of time, 4 to 8 months or so. In recent years, there have been quite a lot of research around the topic, but there are still outstanding questions about how flash drought varies by region, season, and how best to monitor, predict, and plan for its impacts. There's even discussion around whether we should address flash drought differently than other types of drought. But the researchers and practitioner communities are on it. And we invite you to visit drought.gov to check out our flash drought resources page. Toward the end of this presentation, you should have your cameras ready for a QR code link to some key materials on the drought.gov information portal. Next slide. To kick off the effort, in December 2020, NIDIS brought together 120 researchers, practitioners, and other interested stakeholders for a 3-day collaborative workshop to explore and expand our understanding of flash drought. There was an effort to co-develop, emphasizing co-develop, a path forward on research activities and product development. Outcomes from this workshop form the basis of our initiative. Next slide. 2020 and 2021 initiatives were a literature review and workshop report that are available online, promoting information sharing and partnership opportunities, flash drought tool development, aligning flash drought projects with the National Coordinated Soil Moisture Monitoring Network, which my colleague Marina Smanich will address later in the webinar, and facilitating regional discussions on the topic. And most of all, organizing a 2023 flash drought workshop supported by a technical advisory group. Next slide. So in May of this year, we did have that second National Flash Drought Workshop. Next slide. The workshops were attended by 80 in-person attendees, 120 registered virtual participants, and they were researchers, practitioners, graduate students, early career scientists, and veterans who've been working on flash drought and responding to flash drought for many years. There were 24 presentations, 4 posters, and uniquely so, 12 tools that were shared interactively in the Tools Cafe. Of course, there were breakout sessions for brainstorming opportunities, case studies to review, and panel discussions. Because we also were very aware of the regionality of flash drought, there was a special breakout session dedicated to regional flash drought exercise scenarios with response inputs from state drought task force members and researchers. Next slide. At this workshop, we discussed that some regions see either rapid onset or rapid intensification. Some regions see both. Some regions see flash drought even in a wetting climate scenario, as in the Northeast US. Sector impacts were discussed, and the fact that they vary by time scale or geographic extent. For instance, agriculture might see impacts quickly, but transportation or energy sectors may see impacts only with intensification. The final report is forthcoming, but what you see on this side is a list of the major focus items, contextualizing flash drought for those regions and sectors, raising the bar on condition monitoring, encouraging additional research and improvements to 8 to 14 day and 3 to 4 week precipitation forecasts, making all that data and research more accessible, as well as improving our impact-based early warning guidance, message sharing around rapid deterioration events in particular, and we need to focus on gaining a better understanding of flash drought risk and its frequency of occurrence, especially the economic impacts of those events. And of course, we'll continue to convene and can share all that is known about flash drought. Next slide. Now that's a lot, so we have to prioritize. We've taken a look at focusing on these items: indicator improvement linked to region, season, and impacted sectors, increasing the understanding of unique characteristics, predictability, and the risks of flash drought amid transitions between hydrological extremes and in a non-stationary climate system. We want to identify solutions for flash drought planning, communications tools, mitigation and response, and again, those 3 C's: collaborate, coordinate, and communicate about flash drought. Now, this is where you'll need your cell phone cameras. You can use the QR code on the next slide or click on the link to access the tools featured at the 2023 workshop. They're available on drought.gov, and we appreciate your feedback on their performance and possible enhancements. Just reach out to any of your NIDIS dues coordinators with that feedback. Thanks, everyone.
Great, thanks, Sylvia. And we will have all those links in the recap. Now I'd like to pass it over to Jeff, who's going to share with us experience from working on the ground during the recent 2023 Midwest drought. Thank you, Jeff.
Thank you. Next slide, please. I was looking at before we get into the drought, we got to look at what happened prior to the drought. First, looking at the antecedent conditions for the meteorological winter. Over on the left image, we have the precipitation that occurred. Anywhere from about 3 to 8 inches of precip fell across the area during the winter. The middle slide shows the departures from normal. So we're looking at things that were about 2 inches above normal to as clear up to about 4 or 5 inches above normal. And the final image over on the far right actually shows the percent from normal, and we're looking at areas 175 to 300% of normal. The winter was the wettest meteorological winter for Wisconsin, and it was the second wettest for Iowa and Minnesota. Next slide, please. As we got into spring, this is looking from March 1st to mid-May, May 15th. We started seeing some drying taking place across the far southern parts of our forecast area in northeast Iowa and southwest Wisconsin. So we started to dry down there. Meanwhile, it remained wet pretty much north of Interstate 90, which pretty much dissects the center part of our forecast area through La Crosse and Rochester, Minnesota. So we started drying out there. Next slide, please. One of the things we ended up with all that snow cover up to the north and all that came down, melting down towards us. We ended up with our anywhere from the 3rd to our 5th highest crest in the upper Mississippi River Valley. Here in La Crosse, we were the 3rd highest, only exceeded by 2001 in 1965. So at this time, we're pretty much hoping for better case scenario with the flood wave coming through in late April and early May. We're sort of looking for dry weather to come into the area, but you gotta be careful what you wish for because we end up getting into a drought. So next slide, please. When you look, this is the precipitation anomalies and the percent of normal from May 16th through September 21st. As you notice, right around this time, everything pretty much went dry across much of the forecast area. We're looking at much of the area seeing 25th to 50th percentile of normal as far as precipitation goes. So we're drying up rather quickly. Next slide, please. This is the precipitation for Rochester, Minnesota through May 15th. It was, as I said, very wet across the region. It was the 2nd wettest start to a year through May 15th. Only 1887 and 88 was wetter with 18.46 inches. We had 17.40 inches of precip there. Rochester typically sees about 35 inches a year, so about half your precipitation occurred prior to May 15th here. Now let's show the dryness in the next slide here. We only picked up 5.55 inches of precip from basically May 16th through September 22nd. That was the driest on record for that time period. Only 1976 was drier with 6.28 inches. So exceptionally turned the switch from being very wet to very dry. And that seems to be what we see of a lot of our droughts in the region. Here is basically we see a very wet period and quickly the precipitation shuts off and then we end up seeing a very dry period following this. This was exceptional. Next slide, please. This shows what the calendar year basically is up through September 21st at the time. So, and the dotted line shows where we were well above normal as far as precipitation. And then you can just see a long flat line to the right of that line, the pink one there, showing the very little precipitation that we saw through mid-September or so. So right around about the end of June, early July, we actually started seeing negative anomalies for the year showing up at Rochester. Next slide, please. These are temperature anomalies for each month from May through September. May was fairly warm in the western parts of the area, up to 5 degrees above normal. June continued that warmth. Fortunately, July actually ended up being up to about 3 degrees cooler than normal. And then we started warming up again for August and especially September, where the entire area was about 2 to 6 degrees above normal. Next slide, please. This is next 3 slides are going to be talking about just showing how the drought developed on the U.S. Drought Monitor weekly. So initially, just some normally dry conditions in May across our far south from the dryness that started in March down across the southern parts of the area. By late May, we started to see a normally moderate drought started to show up, and that drought continued to slowly intensify. Again, the temperatures weren't exceptionally above normal, so that slowed down some of the deterioration that occurred. Next slide, please. As you can see, we start to continue to develop. We started developing D3, started showing up into that area by mid-July. And then as you start getting to around August 15th through August 22nd, then August 29th, you see a rapid development of the D3 across the area. By the time we got to August 29th, that was the most D3 that we had ever had in our forecast area while the U.S. Drought Monitor has been in existence. And as we continue into the next slides, next slide, please. You can see that we even developed D4. That's the first time we'd ever developed a D4 in our area. And by September 5th, we had already had D4 into our area. And by September 9th, we actually reached the maximum for D3 and D4. That's the highest extent that we've ever had in our forecast area. For D3, you'd have to go back to like 2003, and that was only about 20% of the area. So that's pretty much almost just about half of our forecast areas, either in D3 or D4. Next slide, please. One thing that we typically, as far as fire seasons go, we're starting looking at impacts during this drought. Typically, we see our fires pretty much in the spring, and we did have a fairly active spring fire weather season, but and then we have a secondary one in autumn. However, we typically don't see a lot of fires in the taking place in the summer months. So looking at the number of acre fires that have burned, we had 224 fires in the month of June. That's for the entire state of Wisconsin. A lot of those were across central parts of Wisconsin. That's where a majority of those fires ended up being. And then as you go into July, we actually had the most acreage burned for any month of these months, and that was 815.16 acres burned. And as you can see, a lot of them are in central Wisconsin as far as burning goes. Next slide, please. One thing that is sort of interesting with stream flows can be rather complicated across the area. When we got to about July into mid-September, a lot of the streams in central part of Wisconsin actually started to dry out. But if you notice, there's a lot of green circles showing up on these, and we're ending up with normal flow. One of the issues we have here is a lot of our rivers are groundwater fed. So as a result, by having a wet and seeded winter coming in, very wet, we had a lot of groundwater still there. That actually kept our flows up, so we ended up having a lot of normal flows. And this is not too unusual for droughts in our area, especially if there's short-lived droughts after a very wet period. Our rivers are very slow to respond as far as seeing that. So the ones that were below normal in this map are pretty much areas that are not stream fed. The ones that are green are normal. And that actually caused some issues when we tried to deteriorate some of our drought, because it was trying to normal in most places, the rivers and streams will follow. As you lose precipitation, the rivers will follow. But the problem with ours is being groundwater fed. We're sort of a little bit opposite there, that the groundwater can keep levels up long enough that it takes several months, sometimes even 9 months to a year before we actually start seeing response from there. So something different about our forecast area than many. Next slide, please. One of the impacts that we did have as far as agricultural concerns came was that back in early part of the season, we had a fairly decent hay crop at the beginning back in May, but by the time we got to our second and beyond, as far as the next hay harvest goes, there was a little regrowth because we were not getting much rain at all in the forecast area. And I was talking to several farmers there that were even debating whether it was even worthwhile to even go out and even harvest hay, because they were thinking they may only get one of those large round bales per acre. So by the time you consider fuel prices go, that was a big issue there. Hay prices in the Midwest actually maximum actually ended up being about $170, and that's for premium hay. And then a little bit lower, the mean was about $160 per one of those round town bales. And typically we're looking at normal of around $40 per bale when you have a normal rainfall year. So they were exceptionally high across the area. In some cases, 200 to 400% of normal. Next slide, please. This is looking at the Vegetation Drought Response Index. And one of the things that was interesting about this drought was we were not getting a lot of reports of impacts when we call out to farmers to see what was going on. There they'd say, oh yeah, my corn's green, my soybeans are green, we're doing well. So if you start looking in June, there was not much showing up at all. And this is for southeast Minnesota. You'll see in some of the other ones, I'll show a little bit here. Same thing showing up there. Very little reports of anything. Part of the reason why we have that issue is that some of the drought hybrid corns and soybeans that are out there actually stay green way longer, it seems like, in these situations. We also had groundwater where the roots could still reach the water from the winter, some of that water that was sinking further and further down into the soil profile. The roots were still able to tap that, so they weren't being impacted as much. When we started getting towards mid-July, early August, we started to see a little bit more of an impact where we started getting reports of corn. Basically, in the daytime, would start tightening their tassels in a way to preserve water content for the plant. And soybeans would actually flip their leaves. Now, if you look at a soybean plant, the top of the leaf is a little bit darker than the bottom part of the leaf. So when they flip the leaf, it's a little bit lighter, so there's a little less heat into the plant, and therefore there's less moisture stress on the plant. That's a way of preserving moisture. So that's one thing soybeans do. So as we got into about August 20th, we started seeing more of impacts, and then the heat wave, 2 heat waves hit, and then all of a sudden you see the drought, the agricultural stress here. Next slide, please. We can see the exact same thing sort of took place in Iowa. This is Northeast Iowa. By June, we saw a little bit more impact, started down there a little bit earlier, just because that area had started drying out back in March. So it was a little bit faster as far as a little less soil moisture reserve down in that area. As you can see, by mid-August, we were already starting to see signs of severe drought taking place. And then by the time we got to mid-September, it was already there. Next slide, please. This is looking at southwest and central Wisconsin, same thing that we saw at the other ones. Very little impact until you got towards about mid-August, and then by September, it was there. We saw the stress. Next slide, please. Now, I sort of consider this we had the drought slowly developing, and then here comes the 2 bouts of record heat, which resulted in the flash drought. This is when we started seeing degradations of 2 categories in about 2 to 3 weeks. This is where we tended to see that big, fast drought developing and really intensifying across the area. The first one hit around August 23rd to about August 25th, and we ended up with temperatures getting up into the low hundreds, 100 to 105. Some places saw their first 100-degree temperature since 2012, which was the last big drought across our area. Wisconsin, La Crosse had their warmest low temperature of 79, and their warmest low temperature in September of 78 degrees. The second heat burst started around September 2nd and moved to about September 5th or 6th, depending on the location. And we ended up with record heat in that one too. The first one, we didn't see as much on our crops when we looked at the soybeans and corn. We did see some impacts there. We saw the twisting of the stalk as the plant tried to reserve moisture. But by the time we got the second one, we saw premature death taking place in the corn and soybeans across the area, especially in the non-irrigated soils. Those that were irrigating still during the time period, there wasn't as much of an impact. Next slide, please. One of the tools that we sort of looked like as we're heading into this heat wave, we knew that we were probably going to see record heat temperatures possibly coming, and we knew that we had very little soil moisture left out there to things. So we started looking at the risk of the MRC's risk of rapid drought intensification, experimental one, and this is when it first started showing up a little bit. This is based off, they use the GFS as one of their models that they use, and it's updated 4 times a day. And artificial intelligence is also used to sort of learn which factors or which elements tend to do it. One of the concerns in going into this a little bit with us was that the GFS, when you have dry soils, the temperatures in that model are ridiculously too high out there. And we're concerned that maybe it might be pushing this drought tool, rapid drought intensification tool a little too much, but we were curious as far as what was going on here. Next slide, please. By the time we got to August 30th, this was just before the second bout of record heat in the area. It was showing very high to extreme possible. Extreme was just to the west of our area and very high in our area. So we were concern that we were probably going to see this rapid drying place and a rapid drought intensification taking place. We reached out to some farmers and talked to them a little bit prior to this, let them know. We also put some Facebook posts out. Strangely enough, we did get one person that was actually in favor of, was very much wanting to see these warm temperatures taking place. That would seem to be one of the, he was the few and exceptions there as far as that's concerned. Next slide, please. The other one we actually did look at was CPC's one, taking a look at the rapid onset drought risk. And we did see in the risk hazards that it started to come northward. The excessive heat started moving up in their area. This was back in August 19th. This was back in August 11th there. So you can see though, we're starting to move north. Next slide, please. Oops, sorry, go back one. I thought I had 2 slides on this one. You can sort of see the rapid onset drought was more highlighting Oklahoma, Texas Panhandle, over into Alabama. They're not much of an area, but this is also a 1-week thing. So I'm thinking that may have been the bigger impact why it wasn't quite up in our areas the other tool was showing. But it was just something interesting to look at, to see how this tool, this rapid onset worked a little bit and whether it worked up in the area. Did see it in June, it was up in there, up in the northern parts of Wisconsin. So it was up there at that time period. So it was just something to look at, see how this tool works at. And as I said, typically ours is more in the 2 to 3 weeks. I'm not sure how much this is going to help our area, but it is something definitely to look at. Next slide, please. Other things that we used while the drought was going on to monitor what was going on, we did look at the CoCoRaHS mapping of precipitation. It works great if you've got a higher spatial precipitation grid like you have over Olmsted County over by Rochester. This allowed us to notice that the southern parts of the county was much drier than the southern part, and this was looking at about a 90-day thing. That's one of the limitations for this, because you only look at 90-day periods, but at least you can turn around and sort of plot the data at higher density and see what's there. Also, if you've got some holes in the network, not as quite as useful. Next slide, please. Other tools that we tend to use during this drought was trying to get real-time reports out there. The conditioning, CMOR conditioning monitoring observer reports. We had a lot more in Wisconsin than we had in either Minnesota or Iowa. That was helped because of special thanks to the Wisconsin Task Force, the Wisconsin DNR, the Wisconsin Department of Agricultural Trade and Consumer Protection, and the Drought Task Force, which encouraged people to report what they were seeing on the ground across the state of Wisconsin. So that helped the reason why we got a lot more reports there. We only had 19 in our area. We had 120 in the state of Wisconsin, which I was also evaluating in the state of Wisconsin to report to the Drought Monitor 2. So that helped me to make evaluations across the state of Wisconsin. Next slide, please. Another one that we also looked at was the CoCoRaHS conditioning monitoring observer reports. And this one we got 86 reports. We got a lot more across the area. Unfortunately, some were a little bit restricted to certain counties there. We had 30, for example, in Iowa, 21 were in Chickasaw County alone. So as far as reports there. And then if you look at some of the other reports, Minnesota had quite a bit, but there was 2 counties that reported 35 of the 36 there. So they also helped us monitor what's going on. This report, the farmers around us are suffering from drought. We're watering plants daily. Wildlife are suffering, trying to water reports. Those are the sort of reports that we get. Some are very, very long, detailed reports too. So next slide, please. Now it looks like we're somewhat maybe in recovery now taking place. Since September 22nd through October 14th, a lot of the areas seen anywhere from about 2 to about 7 inches of rain coming into the area. As far as looking at the percent of normal across the area, we're looking at 175 to 250 percentile above normal across a lot of the areas. So we are starting to see a little bit recovery across the area. One of the concerns is if you look at La Nina winters, we tend to be dry. However, if you look at the stronger La Nina winters, we tend to see above normal precipitation. So maybe that's a good sign for a recovery to continue. Next slide, please. Another tool that we used during the drought was the MRS PRISM stage. This is number 84 for Iowa Mesonet. And it was a great tool as far as evaluating. What it does is it plots last week's US drought monitor on top of the precipitation. In this case, I've got the MRS data plotted on it. So I can actually see what the percent of normal for the week is in those locations and help me as far as putting input into state climatologists over Minnesota and Wisconsin, and also gather the input from my own self here in Wisconsin and from the other WFOs and send that information on. Next slide, please. So just a quick drought summary, and that's all I have. Thank you.
Great, thank you, Jeff. And now this is so important because one of the key takeaways from that workshop was that each region is different. And now we are going to pass this over to Molly for a little perspective on messaging and communicating flash drought in the Midwest.
Great, thank you so much, Meredith. So yes, just a few, one more click and then we'll be good. Okay, perfect. So briefly just talking about the regional messaging that comes out from NIDIS and our partners that hopefully, and what our goal is that it corresponds with the local messaging that's happening on the ground. So as it was mentioned at the start of the webinar, NIDIS has our regional drought early warning systems, or DEWs, and all of our regions communicate regional messages of drought through drought status updates. The overall goal of these drought status updates are to provide a cohesive regional message around the potential for drought development or intensification. In this case, in May of 2023, when we started to see signs of flash drought really potentially impacting the region, we did call it a drought early warning update, since at that time, there really wasn't much drought in the region. Of course, you'll see here on this screen, the drought monitor did have some drought in Iowa and Missouri, but besides that, we were pretty much drought free at that point. So the updates that we send out, the drought status updates or drought early warning updates, are sent out to our various regional lists. In this case, the Midwest DEWs listserv, which has a little over 1,000 subscribers. A majority of the people that we send this to are federal and state agencies, the general public, and academic partners. One important piece of information I did want to point out is that we develop these in partnership with many other regional partners, including others at NOAA, like the Regional Climate Services Director, the National Weather Service Central Region, the River Forecast Centers, as well as the USDA and the Midwestern Regional Climate Center. Next slide. So Jeff has covered, the local perspective of what they were seeing, but just from the regional perspective, why we started seeing signs for flash drought in May 2023, based on the recent conditions, across the region, we had dry soils for the most part that were not fully recovered from last summer and fall. So we're kind of have this underlying dryness across the region. And then the month before May, so April, was pretty dry across the entire region, as you can see in that top left map. We also were starting to get multiple reports of dryness across the region. If you look at the National Drought Mitigation Center's Drought Impacts Toolkit, they have a multi-tool where you can look at different sources like COCORAS and the condition monitoring reports. So we started to see some drying reports, and then also the outlooks were showing the potential for some upcoming early summer heat, and that the dry conditions were going to persist, at least for the next couple weeks. And even beyond that, beyond the 2-week point, there were some signs pointing to hot and dry continuing. So we did feel like it was important to get this message out. Next slide. So how we approach this, our drought status updates, we have key points that really get to the message we're trying to convey. We typically start with recent trends. We have current status of drought, and impacts from drought. And then at the end, we have the outlook information and what the potential impacts might be based on this outlook. So the main message for this drought early warning update was that there's a concern with the forecasted weather that this is going to worsen already dry conditions and potentially and quickly induce drought in some areas. So this is the approach we took at the regional level as we're monitoring conditions to communicate to all of our partners. And that's it for me, Meredith.
Great. I'm now going to pass it over to Adam Hartman from the Climate Prediction Center at the Weather Service to talk about new developments on the rapid onset drought risk tool that we heard about previously from Jeff. Take it away.
All right, thank you. So for the better part of 2 years, we've been forecasting rapid onset drought in our week 2 U.S. hazards outlooks. So for those of you who aren't really familiar with the tool, I'm going to start off here with a motivation behind this work, and then I'll talk a little bit about a tool we developed in conjunction with this, the release of this or the implementation of this hazard, and then I'll move on to some of the steps that we've taken to address some of the feedback that we received after the 2022 warm season. So first, the motivation leading up to our early May 2022 implementation. We were receiving a lot of feedback from stakeholders that we wanted drought outlooks, products, tools, and services at shorter lead times. So up until that point, this Climate Prediction Center only released monthly and seasonal outlooks. So that's the 1 month and 3 month lead times, respectively. So using the monthly drought outlook to address the those shorter time scales, using the monthly drought outlook as a kind of a proxy of sorts, we applied tools and methodologies used for that outlook to implement the ability of a rapid onset drought forecast into the week using the week 2 hazards framework. And we ultimately did this to improve communication of rapid onset drought throughout the month. And we do that through various channels, using decision support services, so that we do that through our 1 p.m. briefings, headquarter briefings, as well as our DSS emails to various regions when hazardous thresholds are reached. Next slide. So looking at, excuse me, our rapid onset drought risk tool that was developed in conjunction with this implementation. This is an internal forecasting tool only. We take initial conditions, soil moisture specifically, look at areas that fall below the 30th percentile of historical distribution, and then we overlay deterministic week 1 temperature, precipitation anomaly maps, as well as week 2 probabilistic CPC temperature and precipitation outlooks. And we overlay those together, perform a bunch of various checks, spatial aggregation, and we produce what you see in the bottom right of your screen. That's an example of the output. And we incorporate various soil moisture models as inputs, so forecasters have the ability to kind of tailor the output, or tailor the inputs, excuse me, to produce different maps and take a look. I want to make clear also that this is the onset of drought, so we don't predict the intensification of drought once it develops. So that's a very clear distinction that I want to make. Excuse me. Next slide, please. I'm sorry, I'm fighting an illness. So looking now at user feedback following our 2022 warm season, 2 major takeaways from that, from the feedback, was people wanted to see verification. In addition to that, there was an issue related to the release frequency. So during 2022, we were releasing rapid onset drought risk hazards daily. So we would change these lines daily, pushing, pulling. Shapes would pop up some days and not others. And that was based on, the forecast information available at that time. So based on the feedback, those day-to-day changes were just too variable with a daily release schedule. In addition to that, unbeknownst at the time to the users, to the end users and stakeholders, we were already struggling with how to verify daily forecasts using weekly observations, which we use you'll see shortly we'll use the U.S. Drought Monitor to do that. So the release frequency and the verification are very much intertwined on our end, and the resolution was to change the release schedule. So now we release rapid onset drought risk hazards Thursdays only between April 1st and October 31st, what we consider the warm season, coinciding with the U.S. Drought Monitor release. And we've also implemented the potential for updates on the following Mondays. Excuse me, next slide. So talking more about the verification aspect, this is, so first and foremost, in the U.S., the week 2 U.S. hazards framework, rapid onset drought is defined as the 2-category degradation from non-drought to drought conditions at any point during the next 2 to 4 week period. And that's according to the U.S. Drought Monitor. So that's how we're verifying it. And for those of you not familiar with the U.S. Drought Monitor, the U.S. Drought Monitor depicts various non-drought and drought intensity levels. So if you look just below the red text there, I have in the red box, you know, the white areas, and an example of that map is in the bottom left of your screen. So the white areas represent there's no abnormal dryness or drought. Yellow areas represent where there's abnormal dryness, but that does not mean drought. All other categories are various intensities of drought in the U.S. Drought Monitor map. So rapid onset drought risks target these first 2 categories, the no abnormal dryness or drought and the D0 or abnormally dry areas. And we look for 2-category degradations. And below that is just a general schematic. I'm not going to go into details too much, but general schematic of the verification workflow where we take our forecast and observation shapes and we create grids and throw them into the National Weather Service Model Evaluation Tool, or MET. And that MET tool is very useful. It pops out a bunch of statistics all at one time. It's beautiful. Includes high key skill scores, critical success index, or CSI, also known as the threat score, as well as the symmetric extremal dependence index, or SETI, among many others. Next slide. And this is an example of the critical success index, specifically from Thursday. So I mentioned we have an official release on Thursdays and then a potential for an updated release on Monday. So we verify those independently. So looking at the Thursday, we have on our top row CSI scores for the 2022 warm season. On the bottom row, we have CSIs aggregated over the 2023 warm season so far up to, I think it was, September 14th. In the left column, we have the CSI with misses. You know, if you think of your 2x2 contingency table, your hit, miss, false alarm rate, we have the CSI score with misses included. In the middle column without misses, so excluding any misses. And then I've also provided forecast sample size plots in the right column. So looking first at the left column, you can see our CSI scores are pretty low. Now there's various reasons for that. One of the major reasons, obviously, is the low sample size. We've only been doing this for 2 seasons. In addition to low sample size, you know, obviously we haven't had the opportunity to forecast drought very often in many areas. In addition to that, you know, large portions of the Midwest and Central Plains have been in drought, you know, for large portions of the 2022 and 2023 warm season. So that's also kind of diminished our ability to forecast for those regions. So with misses, our CSIs are drastically down, so not surprising. So I wanted to kind of eliminate the misses, to see how we were doing when we did forecast drought in those areas that we did forecast drought. So I excluded the misses in these middle plots. And you can see our skill score nearly doubles for the 2022 warm season and nearly triples even for the 2023 warm season. And, you know, that's a testament, the increased scores from season to season is a testament to forecaster improvement in forecasting drought, more than likely. So what I want you to really take away from this is, you know, in areas where rapid onset drought risks are posted, we do actually do a pretty decent job. with respect to the white space, so your left column, where the CSI with low CSI scores, there's a lot of caveats to that. So a lot of that degradation, so CPC really looks for kind of statewide to regional wide impact, like scale, those types of scales for releasing rapid onset drought risk hazards. Over those seasons, a lot of that white space is likely due to, kind of creeping two category degradations. You might have a little bit here one week, some improvement, might stay status quo for a while, and then the next couple of weeks, you'll see some more degradation again. So these kind of continuous small episodes of drought expansions spanning several months, essentially. In addition to that, D0 duration leading up to the forecast valid period is not accounted for. So let's say a D0 area, an area is experiencing abnormal dryness for 4 weeks or more. Should we be counting that as drought? I mean, is that slow enough? I mean, the abnormal dryness was there for a very long period leading up to the forecast period. So that's not accounted for in these maps. So things to consider. Next slide. And to kind of drive that point home about, looking more at how well we do when we do forecast, I've provided the Symmetrical Extremal Dependence Index, or SEDI index, and that basically just kind of cut off at the bottom there. It basically just looks at hits and false alarms and compares the two. SEDI's pretty decent at assessing general performance of a forecast and its ability to predict extreme or rare events, and that is what we deal with in the hazards framework. Values above 0 imply a forecast is better than random chance. Your score is maximized when your hits approach 1, a perfect score, and your false alarms approach 0. And as you can see, the SEDI scores here for the 2022 warm season in the top left, and the warm season in the top for 2023 in the top right, you can see our scores really well above 0. So we're looking at various metrics and how they perform, and are analyzing them, as we go along. Next. So the big takeaways from this. There we go. We've updated the rapid onset drought release schedule. Again, Thursdays are official release, but we have the potential for Monday updates, and those fall between April 1st and October 31st. What we call the warm season. We have taken steps to perform the quantitative verification of rapid onset drought using standard skill metrics. Obviously, sample sizes will take some time to grow, but overall results do look promising in areas where rapid onset drought is forecast based on multiple skill metrics. And we're looking into adjustments related to drought depictions leading up to the forecast period, as well as a potential spatial coverage threshold for issuance. And as we head towards fiscal year 2024 and following likely a review period for 2023 results, CPC will likely look to move toward operational implementation of the rapid onset drought, as right now it is experimental. And with that, I have nothing else. If you have any questions, comments, please reach out to our drought point of contact, Brad Pugh, or myself. Thank you.
Great. So much, Adam, and you get bonus points for presenting while not feeling good, and for saying that statistics are beautiful. So thank you. We're going to wrap up these last couple of minutes with Marina Skumanich from NIDIS to talk about some developments and resources for soil moisture, which, as was identified earlier, is so connected to flash drought monitoring and prediction. Marina.
Thank you, Meredith, and hi, everybody. Thanks for hanging in here, and I'll be pretty quick. I just have a couple slides. Just to start, though, I want to give the context. Again, this was mentioned earlier. NIDIS has been leading this interagency, federal, state, university, et cetera, partnership to develop a National Coordinated Soil Moisture Monitoring Network, or NCSMMN is our acronym. And it's really intended to deliver coordinated, high quality nationwide soil moisture information for the public good, specifically the kind of resources and tools that can help folks like you. And so next slide, please. So the question you might ask, I hope many of you have an opinion on this, but why soil moisture in the context of flash drought? Why would that be particularly important? Well, there has been widespread recognition that soil moisture can provide an early warning for flash drought that otherwise may be missed. One of the examples is this 2017 Northern Plains flash drought, which was a rapid onset catastrophic event, absolutely not anticipated. And the after action report indicated, among other things, it's really important to consider more soil moisture monitoring to help provide that early warning. Part of the reason that soil moisture is a good indicator for flash drought is it captures both, it reflects agriculture and ecological impacts sort of early on, or potential for agricultural ecologic impacts early on. And that's partly because it captures at the same time the effects of both precipitation and evaporative demand. If you're looking at just precipitation or just evaporative demand, you might be confused about, is there going to be a flash drought? But when both of those can be combined in the same thing, soil moisture being one of those indicators, then you have this low false positive rate. Conditions, rapid changes, rapid reductions in soil moisture are likely to be suggesting there could be a flash drought. So that's the strength there. But there are some considerations in using soil moisture tools. One of them is the uneven current distribution of in situ monitoring, which means then we are relying on models and remote sensing, and those are great sources of information, but we do know we need better validation and better understanding of exactly the dynamics, so we really know what's exactly going on in the soil. And I think this is true for a lot of other indicators, but given that we're relying on models, we don't exactly know what ground truth is. It does require experience to fully interpret any kind of indicator that you're tracking. So next slide, please. What I'm going to do is just very briefly touch on a couple web resources that NIDIS has on drought.gov that can give you a portal or pathway to some soil moisture data and maps. This first is this tab at the top, data and maps tab. We have a soil moisture page that will give you some background on soil moisture, how it's measured, et cetera. And then again, a gallery of maps and tools, kind of a portal to other tools and models, et cetera, that you can monitor as you're looking to identify if there's a potentially flash drought. There are also some web links and other resources for more background. Next slide. But in particular, I wanted to point out to you this drought indicators soil moisture product dashboard. This is a part of a suite that NIDIS is developing on drought.gov to provide a little bit more tailored information for those of you who, such as yourselves, weather service folks or state climatologists, who really need a little bit better ability to hone in on a particular area that's your area that you have to focus on, and then compare perhaps one map to another to kind of get a sense of, well, what are different models suggesting, and where would I find kind of the real quote unquote truth of the conditions. So this product dashboard, there's a link there, and I'll make sure we get links into the chat and with the webinar recap. But this is a way for you to, again, to look across several of the key soil moisture models that can give you some indication of conditions that might reflect a flash drought. And I think that's it for me. I want to mention that in addition to the CPC rapid onset, which is also bringing up using soil moisture as a driver, there are going to be a couple others coming up soon too, soil moisture based flash drought tools that I'm hoping we can announce in the near term. So stay tuned for that.
Great. Thank you, Maria. That is very exciting to hear about more tools, and we'll make sure that we share that. In the last minute, I just want to flag that, again, this is the second in a 5-part webinar series. The next one, a registration email will go out soon, will be on December 6th, where we're talking about assessing drought in a changing climate. And with that, I would just like to remind you, we will be sending out a recording and recap. If you have additional information, please feel free to contact myself or Maggie Hurwitz from the National Weather Service. And I want to thank you all for joining us this afternoon. If you sent in some questions, we will reach out to you separately. Have a great day.